Today in the workshop, we'll be working with the heart of the Arduino, the ATmega328 chip. We'll learn how to use an ATmega328 to replace an Arduino Uno in our projects. We're getting down to basics today, so welcome to the workshop. Hello and welcome to the workshop. Now here in the DroneBot workshop, you've seen me build a number of projects with an Arduino, and most of the time I have used the Arduino Uno. The Uno is a very inexpensive Arduino, especially when you get one of the clones, and it's probably the most popular Arduino, and this is one of the reasons I've chosen to use it for most of my projects. However, there comes a time when you're finished with your project and you may like to make a permanent version of it. And when you do, you have a number of choices. One of your choices, of course, is just to use the Uno itself and build it into an enclosure along with the rest of the components or shields that you need to complete your project. And that's an excellent choice, but naturally that ends up using your Arduino Uno, and if you want to do some experimenting, you'll need to get another Arduino Uno. Your second choice is to go and use one of the smaller models of Arduinos. Now there's the Arduino Nano and the Arduino Pro Mini. The Nano is a great little device. It pretty well emulates everything an Uno does. It even has 2 extra analog pins on it, and it has a USB connector, etc. It can be used in place of an Arduino Uno just fine, and as it's much smaller, it'll probably fit into a smaller enclosure. The Arduino Pro Mini is even tinier, but it lacks the USB port, but your project may not even need a USB port, so those are both very good choices. But today I'm going to talk about a third choice, and the third choice is to use the actual chip, the actual microcontroller unit that is on the Arduino Uno, and that chip is called an ATmega328. Now, the ATmega328 is available in both a surface mount package and in a 28-pin DIP, or dual inline package, and it's a 28-pin DIP that we're going to be working with today. You can take your Arduino project and take everything and put it onto an ATmega328, and then all you need to do is add a few components to it, basically a crystal, a couple of capacitors, and a resistor, and you've got a complete working circuit that emulates everything you can do with your Arduino Uno, assuming that you don't need a serial port. And if you do need a serial port, there's a way around that as well. So today what I'm going to show you is how the ATmega328 works and how we can take an Arduino project and move it down to the ATmega328. And what I've done for this is I've got a very simple but rather cute Arduino project that you can build, and then I'll show you how we can set it down onto a chip, which you might want to do if you're making a printed circuit board, if you're mass producing your project, or if you just want to make a very tiny permanent version of your project. So let's go ahead and learn a little bit about the ATmega328. So let's take a closer look at the ATmega328. The ATmega328 is a single-chip microcontroller. It was originally developed by Atmel. Atmel was bought by Microchip Technology, who now own the patent to the ATmega328. It's an 8-bit RISC processor. RISC is a reduced instruction set computer. It has 32 kilobytes of flash memory. It also has 2 kilobytes of static RAM and 1 kilobyte of electrically erasable programmable read-only memory, or EEPROM. The ATmega328 is available both in dual inline package and surface mount packages. The processor has 23 general-purpose input-output lines. It has 32 general-purpose registers. The ATmega328 also has 3 timer counters. It has both I2C and SPI interfaces. It has either 6 or 8 10-bit analog to digital converters. The DIP package only has 6 of them, whereas the surface mount package has 8 of them. This explains why devices like the Arduino Pro Mini and the Arduino Nano actually have 2 extra analog to digital converters compared to an Arduino Uno. It has both internal and external interrupts. Now we'll be using the DIP or dual inline package version of the ATmega328. Here are the functions of the 28 pins on this package. You will note that most of the pins have multiple functions. And here's the same pinout described in relation to the pins on an Arduino Uno. So now let's start using the ATmega328. So now that we've learned a little bit about the ATmega328, I want to show you the Arduino project that I'm going to build and then transfer to run on an ATmega328. Now the project is very simple. In addition to the Arduino Uno, it requires a couple of resistors, a couple of LEDs, and a piezoelectric buzzer or sounder. Now you may not have a piezoelectric buzzer or sounder, but they're very commonly available. You can get them on eBay or Amazon. You can also probably pick one up at your local electronics store, assuming you have a local electronics store, and that's actually where I got mine. Now what our project is going to do is it's going to play a simple little tune on the piezo buzzer, and it's going to flash the LEDs in time with the tune. Now if you're a Star Wars fan, you'll probably recognize the tune, and you'll probably see that this would be a good circuit to build into an old toy. If you have a Darth Vader or Stormtrooper toy, this would actually be something excellent to build inside it. And when you do that, of course, you're not going to want to use a whole Arduino Uno. Something like an ATmega328 is ideal for this. So I'm going to show you the code, and then I'm going to show you our little toy in action, and then after that we'll see how we can move the whole thing over to an ATmega328. So here's how I hooked up our music box project using an Arduino Uno. In addition to the Arduino Uno, I have 2 LEDs. I chose a red and a green one, but you can use any colors you like. I also have 2 dropping resistors for the LEDs. I use 220 ohms, but any value from 150 to 330 ohms would probably work just fine. I also have a piezoelectric buzzer. This is a very inexpensive component that you can probably pick up online, if not at your local electronics shop. I started by wiring the positive terminal of the piezo buzzer to pin 8 of the Arduino Uno. I then connected the other side of the buzzer to the Arduino Uno's ground. Next, I wired my red LED through the dropping resistor to pin 13 of the Arduino Uno. The green LED goes through its dropping resistor and is connected to pin 12 of the Arduino. Finally, I connected the cathodes of both of the LEDs to the ground. And that completes the wiring. So let's look at the sketch that we'll be using for our Arduino musical box. Now this sketch is not my own creation. This was downloaded from GitHub, and it was originally written 6 years ago by a gentleman named Nick Sort, and many people have enjoyed his fine work, and I am just one of them. So with that said, let's go through how this sketch works. Now at the beginning we define a number of constants, and these constants represent the musical notes and the frequency of that specific musical note. Now if you know something about music, you might recognize a few of these. For example, this one, A at 440 Hertz, is also referred to as A above middle C because of its position on a grand piano keyboard. And this is a very common frequency for tuning forks. And so you can see the frequencies we've defined for a C, a D, an E, an F, a G sharp, an A sharp, and a B. Now these ones with an H after them are an octave above the ones before, because octaves work by a doubling of frequency. So for example, the A above middle C we have here is at 440 Hertz. If you go to the bottom, we have an A in the next octave, which is twice the frequency of 880 Hertz. Now, if you want to expand this and play a different tune, you can expand the range over here. This only does a small range of all the octaves that will be covered by a piano keyboard. But keep in mind that the tones at the high end and the low end of the keyboard are not going to be reproduced properly, if at all, on the piezo buzzer that we're using. And so after defining the musical notes, we just define a few other constants. The buzzer pin, which is pin 8, where we've connected our piezoelectric buzzer, LED 1 on pin 12, and LED 2 on pin 13. We also define an integer for a counter, which we will use to step through the music. Now in the setup, it's very simple. We simply set all of the pins out as outputs for the buzzer and the two LEDs. Now before we go in the loop, I want to go and show you a function because it's the key of making this work. And the function is called beep. And beep takes two inputs, two integers, the note, which is one of the notes we defined earlier, and the duration in milliseconds that we will be playing the note. And it uses the tone function. Now the tone library is one of the built-in libraries in your Arduino IDE, which is why it doesn't need to be declared in this program. And so basically we use tone to go to the buzzer pin, the piezoelectric buzzer, and we play the note, the frequency of the note that has been sent to us for the duration in milliseconds. And here we dance the LEDs, and here's where the counter goes. Now we take a look to see if the counter is even or odd. That's what this first statement does, to see if it's a multiple of 2 or if it equals to 0, because we're including 0 as being an even number in this case. Now, if it is an even number, then we go to LED number 1, and we turn it on, and then we keep it on for the length of the duration that we've been passed at the top here, and then we turn it off. If not, we go and we use LED 2, and we use the same thing. We turn it on for the length of the duration, and then we turn it off. Then after that, we stop the tone on the buzzer, and then we delay for 50 milliseconds, and then we increment the counter by 1. So the result of this is every time we call beep, it will play the tone for the duration that we wanted, and it'll flash one of the two LEDs on for the same duration, and then delay itself for 50 milliseconds. And so now that you've seen beep, we can go and take a look at these other two functions. Our music is defined by a couple of different sections because it repeats over and over again. So Nick has just simply chosen to make these into functions, and this pattern goes on and on and on. Basically, you call beep with the tone that you want to play, the note. Here you're playing an A for 500 milliseconds, another A for 500 milliseconds. Remember, there's going to be a 50 millisecond delay after each one of these. And then after this section, you delay for half a second and play some other notes, delay for half a second. The second section works in a similar fashion, just with different notes. And if we go back up to the loop, we'll find that's pretty well how the loop works. In the loop, we play the first section, then we play the second section, and then we do what he calls a variant, which is just a bunch of different notes that don't belong in either section. Delay, we repeat the second section, do another variant, we delay again for a different period, and play the loop over and over again. So the loop represents one entire play of the tune, which just repeats itself over and over. So now that we've seen how the musical sketch works, let's load it up to Arduino and take a listen to our Star Wars musical sketch. So I've loaded my musical sketch up to the Arduino. I've disconnected the USB cable for the moment so it doesn't start playing right away. And as you can see, I've got my piezo buzzer, which is wired one side to ground, the other side to pin 8. I've got my green LED with a resistor, a dropping resistor here, and that's wired up to pin 12, and I've got my red LED with its dropping resistor wired to pin 13, and then a connection over here just brings back the ground connection. And so without further ado, let's plug it in and listen to our fabulous tune. and it plays over again. Now I'll be the first to admit that it's not quite the London Symphony Orchestra, but as you can see, this would make an amusing little Star Wars toy. So now that you've seen our little Star Wars music box, it's time to move the code down to an ATmega328. But before we do that, I need to discuss one more thing with you, and it's something called a bootloader. Now, what exactly is a bootloader? You may or may not have heard the term before. Essentially, and this is a really simplistic explanation of this, a bootloader is code that is already loaded on the chip. And when you boot the chip up, it loads this code, and the code sets up a number of things. It sets up the speed that the processor is going to run at. It sets up a number of internal registers, and it also prepares the chip to be able to receive commands over its serial line and to be programmed. Essentially, a bootloader is what the difference between a raw microcontroller and an Arduino is. And the Arduino bootloader is open source code that you can load onto the chip yourself. Another option, however, is to buy an ATmega328 with the bootloader already on it. And that's what I've done today. Now, I'm not going to demonstrate how to load a bootloader onto a blank ATmega328 simply because I don't have a blank ATmega328 without a bootloader. I've checked, and all of the ones I have in stock already have the bootloader on it. But you can buy an ATmega328 without the bootloader and load it yourself. Now, if you want details on that, the article that accompanies this video on the DronebotWorkshop.com website explains this in some detail and also will give you links onto how to do it. There are a number of methods to do it. You can do it using an Arduino itself to load the bootloader onto a raw chip. You can also buy special devices that are made for loading bootloaders. And if you're mass producing things and you want to get the best value, then this is the way to do it, because chips without the bootloader are cheaper than those that already have the bootloader. But again, I've already got mine installed, so I'm not going to go through this process in the video simply because I don't have a chip to demonstrate that with. So if you are ordering an ATmega328, one thing to note is that usually ATmega328 PUs have the bootloader installed, whereas if they don't have the PU designation at the end, they probably don't have the Arduino bootloader. So with that in mind, let's take a look at what's required to wire up our chip to emulate an Arduino, and then we will see what we have to do to load our code onto it. Now here's the basic hookup for the ATmega328. In addition to the ATmega328 chip, you will need a 10K resistor and a 16 MHz crystal, two 22 picofarad capacitors, as well as a 10 microfarad electrolytic capacitor. This, by the way, is optional, but it's a good idea to include it. You'll start by wiring pin 7 of the ATmega328 to the positive 5-volt line from your power supply. Then connect pin 8 of the ATmega328 to the ground side of your power supply. You'll also connect pin 22 to the ground and pin 20 to the 5-volt supply. Now we will wire the reset line, which is on pin 1. Connect pin 1 to one side of the 10K resistor. The other side, connect that to 5 volts. Next we'll connect the crystal to pins 9 and 10 of the ATmega328. Crystals are not polarity sensitive, so you can put them either way around. We'll also connect one side of the 22 picofarad capacitors to each lead on the crystal. The other side of the capacitors will be connected to ground. Finally, we will connect our 10 microfarad capacitor across the power supply lines. Make sure to observe the proper polarity here. And this completes the wiring of our ATmega328. So here's my ATmega328 wired onto a solderless breadboard, and you can see right now that I'm running the blink sketch. What I did was I connected a resistor over to pin 19, and then from the resistor I connected an LED over to ground. Now pin 19 on the ATmega328 is equivalent to digital I/O pin 13 on an Arduino Uno, so as you recall from the blink sketch, its purpose is to blink the LED that's attached to pin 13, and it's doing this right now. I will show you in a moment, of course, how I got the code onto the ATmega328. Now you can see some of my components here. If you look carefully, here's the crystal and the two 22 picofarad capacitors, and over here is the 10K resistor that's tied to the reset line, and otherwise I've got the voltage and ground lines connected accordingly. I've also put a 10 microfarad capacitor across the supply line. This is optional, but it's a good idea just to keep any noise off the power supply line. And so there you go, an Arduino on a breadboard, and as you can see, it's significantly smaller than a complete Arduino Uno, and if I were to put this onto a perf board or a printed circuit board, I could make it even tinier. And I'm powering everything, by the way, off of the 5-volt power supply that I have on my workbench. You'll need a good source of 5 volts in order to do these experiments. You could use a USB power adapter if you have a power adapter that you can run a couple of wires from, and that would work just fine as well. So now that we've seen this, let's move on. So now that we've seen how we can take an ATmega328 and wire it up with a crystal and a few capacitors and a resistor to emulate an Arduino, we now need to know how we can take our sketch and load it onto the device. In actual fact, there are 3 different ways you can do this. Now, the first 2 methods are going to require a particular style of Arduino. I've got a couple of Arduinos down here on the workbench, and this is the style that you want. Now, I'm hoping you can see that. This Arduino Uno uses a 28-pin DIP or dual inline package, and the chip is mounted in a socket. And this is actually how the original Arduino Uno was built, and several clones are built this way. If you are using this type of an Arduino, then I have 2 methods that you can use this Arduino in order to take the code from your Arduino IDE and load it onto the ATmega328. Now, if you don't have this style of Arduino and have this style instead, now this is a style that many clones use. They use a surface mount version of the chip. And with this type of Arduino, you're not going to be able to use the first 2 methods that I talk about. So I have a third additional method that's going to require an additional component that you can use to load code onto the ATmega328. So with that said, let's take a look at the first and by far the simplest method of taking the code that you write on your Arduino IDE and moving it onto an ATmega328 chip. So I've taken the ATmega328 out of my Arduino Uno and I've inserted it on the breadboard. Now, when you're taking the chip out, there's a couple of things you can use. This is a chip puller, and it grabs the chip around the edges like this, and you can use it to haul the chip up, and it's kind of useful. If you don't have something like that, though, you can just use a flathead screwdriver and just go under each end of the chip to lift it up. Now, in both cases, you want to be very careful not to bend the leads on the integrated circuit. So be very careful when you do that. Take a look at the leads when you take it out. That's also very true when you insert it back in to the Arduino Uno after you're finished with the experiment. Now, otherwise, I've taken the LEDs and the piezo and I've moved them over to my Arduino on a breadboard circuit over here with the ATmega328. And I'm going to be powering it once again using my bench power supply. So again, this chip has already been programmed in the Uno and I've just simply moved it over here to the breadboard. So let's put some power onto it. And away we go. Okay, so that is certainly the simplest way of doing it, but probably not the best way of doing it. So we'll look at another method in a moment. So the first method of loading a sketch onto an ATmega328 was very simple. Obviously, it's just exactly the same as loading code onto an Arduino and then just pulling the chip off. There are, of course, some disadvantages to doing that. The first one is that you end up with an Arduino that doesn't have a chip. However, if you've got a number of ATmega328s with bootloaders, then you can just simply replace the chip, and that's fine. The second problem is that the socket on the Arduino clone, or the Arduino Uno itself, is not really made for repeated insertion and removal. It will eventually start to degrade the contacts on it, and as you may have noticed, it's a bit difficult to get the chip out of the socket. Now, one thing you can do is I've got this little shield over here, and you can get similar shields to this. This is a shield for the Arduino, and as you notice, it has a ZIF socket on it. And you take out the chip from your Arduino, you pop the shield in, and you can use this as a socket instead. And so if you're doing multiple runs of a certain build, or if you just want to program a bunch of different ATmega328s, you can use something like this and it'll work fine. But there is another method that I want to show you. Now again, you need the style of Arduino Uno that has a 28-pin dip. You can't use the surface mount one because you're going to need to remove it from the Arduino. But instead of programming that chip and removing it, you're just going to remove the chip, put it aside, and connect the Arduino up to the ATmega328. And I'll show you how to do that in a moment. Once it's connected, you can actually use the Arduino Uno itself as a programmer. So let's take a look at that method right now. Now here's how we wire things up in order to use an Arduino Uno to program an ATmega328. Now you need to start off with the ATmega328 hooked up exactly as I showed you earlier. However, I thought that all of these extra wires and connections would be a bit confusing on the diagram, so I've chosen not to show them. However, keep in mind that they are there. Now we'll just move our ATmega328 to the side, and we'll bring in an Arduino Uno. And on the Arduino Uno, we need to remove the ATmega328 from its socket. Now note that if you have an Arduino Uno that uses a surface mount version, you won't be able to use this method. Once you've removed the processor from the Arduino Uno, connect the reset line to pin 1 of the ATmega328, which is its reset line. Then connect pin 0, which is the receive line, to pin 2 of the ATmega328, and that's its receive line. And finally, the two transmit lines are connected together, pin 1 of the Arduino Uno to pin 3 of the ATmega328. You can also use the 5-volt and ground connections from the Arduino Uno to power the ATmega328. You no longer need an external power supply. And now you'll be able to use the USB to serial converter on the Arduino to program the ATmega328. Now here's my hookup using an Arduino Uno as a USB to serial converter. Now on the Arduino Uno, this red line comes from the 5-volt output, and so it's 5 volts is connected to the positive rail on the breadboard. The black wire is the ground from the Arduino, and it's connected to the negative rail. This blue line goes from the reset output on the Arduino Uno, and it's going to the reset pin on the ATmega328. Now these are the transmit and receive outputs from the Arduino on pins 0 and 1, and they are connected to transmit and receive on the ATmega328. And the transmit is connected to transmit and receive is connected to receive, because essentially we are just using the Arduino Uno as a front end to pass data over to the ATmega328. So I'm going to upload my code right now. And you'll see a bit of activity on the lights. And it's playing our tune. Now one thing I'm going to do is upload a blank sketch to it now. And that basically clears the chip so we can use it for our next experiment. Now the methods we've looked at so far for programming an ATmega328 all relied on an Arduino Uno or Uno clone that has this style, that has the 28-pin DIP chip. And in the first one we just took the 28-pin chip and we took it out of its socket and used it on the breadboard, and of course that worked pretty well. The second method, we also needed to remove the chip, and we used the USB to serial converter, which is this little chip on the board, in order to program the ATmega328 on a breadboard. But what happens if your Arduino Uno looks like this? Now, if you have an Uno clone that looks like this, it uses a surface mount version of the ATmega328. And naturally, you can't easily remove this, and I'm not suggesting that you do. You'll completely destroy the board. And so there's another method you can use to program an ATmega328 on a breadboard that does not require an Arduino Uno at all. And that's to use one of these. These are FTDI adapters. Now these are both equivalent in function, but they're different styles of adapters. One interesting thing about these two different models is that the pinouts here are mirror images. But what these are essentially are USB to serial converters. And you can use one of these to program an ATmega328. So let me show you how we hook that up, and then we'll program our chip on the breadboard using one of these FTDI adapters. So here's how we're going to use an FTDI adapter to program an ATmega328. Once again, we will start with a fully wired ATmega328, and as I did before, I'm going to eliminate those connections from this diagram just so it doesn't get too confusing, but keep in mind that they are there. Now, in addition to the FTDI adapter, you are going to need a 100 nanofarad capacitor. We will start by connecting the receive or RX line on the FTDI adapter to the transmit line on the ATmega328. That's pin 3 on the ATmega328. Then we'll take the transmit line on the FTDI adapter and connect it to pin 2 of the chip, which is the receive line. Next, we will connect the DTR, or Data Terminal Ready line on the FTDI adapter to the reset line, which is pin 1 on the ATmega328. If your FTDI adapter does not have a connection labeled DTR, it may have one labeled RTS, which means Request to Send, and it performs the same function. Finally, you can use the VCC connection and the ground connection from the FTDI adapter to power the ATmega328. Now here's the setup I have with my FTDI adapter. I've got the FTDI adapter and I've got the power and the ground leads from the FTDI attached to the power and ground rails on my breadboard so I can power everything from the adapter. I've got the transmit and receive lines connected to the transmit and receive on the ATmega328, and remember, in this case, transmit goes to receive and receive goes to transmit, so it's backwards from the way that we connected the Arduino. And this blue line over here is my data terminal ready, or DTR line, and I don't know if you can see it, there's a 100 nanofarad capacitor over here, and from there I go over to the reset pin, which still has the 10K resistor bringing it high. And so when I upload the code, what I want you to watch is the lights on the FTDI adapter. And so I'm going to go and upload my code right now. And you'll see the lights flicker as the code's being uploaded. And it seems to be working. May the force be with you. And so that about wraps it up for today's video. I hope that you enjoyed it. I hope you learned something. And most of all, I hope that it's inspired you to take some of your Arduino projects and move them down to an ATmega328. Now, as I said at the beginning of the video, there are other options. The Arduino Pro Mini and the Arduino Nano are both inexpensive, tiny devices. In fact, when you buy them on eBay or Amazon, you can often get them at about the same price as you would pay for an ATmega328, as well as a crystal and a couple of capacitors and a resistor. So cost-wise, it's debatable about whether this is the most economical solution, but it certainly is the most basic solution. The other thing is you can run an ATmega328 without the external crystal and the capacitors, assuming that you want to run it at a slower speed. Now, if you'd like some information about doing that, please check out the article on the website at thedronebotworkshop.com, where you'll find details and links about loading bootloaders onto an ATmega328, and also about using it in modes without the crystals and capacitors. So if you're interested in that, it's all in the article. And while you're on the website, please sign up for the newsletter if you haven't already. My newsletter isn't a sales letter at all. It's just simply a way of keeping in touch with you, letting you know what's going on in the workshop, and most importantly, getting your opinion about the videos and articles that I create and about subjects that you would like to see me cover in the future. So if you haven't done so already, please sign up for the newsletter, and if you haven't subscribed to the YouTube channel, just click the link below the video and subscribe. I would really appreciate that. So until next time, please take care of yourselves, and I hope to see you very soon again in the workshop. Goodbye for now.